To the naked eye, this is just a broken-toothed gear. It's made of conventional steel, composed mainly of iron and a small amount of carbon. This small quantity of carbon is enough to protect the gear from corrosion, but not enough to make it indestructible over time. To increase steel's resistance, other elements are added: nickel, manganese, chrome. This way, hundreds of different types of steel are made. As we move closer, this fracture allows us to discover the structure of the alloy. A rugged landscape materializes. Here and there, a scattering of white specks. They're tiny particles of dust that have settled on the surface. Each of these petal-shaped forms is a particle of steel called dendrite. An alloy of iron and carbon, dendrite is found in all solid matter that crystallizes in cooling. It's found in steel, aluminium, and even in snowflakes. When cooled rapidly, steel increases in strength, a process known as tempering. Between the particles, a cavity is outlined. We'll continue our journey through this hole, which is probably due to the aging of the metal. In the background, a grain of pearlite emerges from the shadows. It's easily recognized by its characteristic sliced structure. The thick black diagonal cutting through the pearlite contains a little more carbon than the lighter areas around it. So do the other thin lines. It's this extra carbon that gives the darker color. The fuzzy black and white flecks are faults in the structure brought into focus by the microscope. At maximum enlargement, a series of tiny regular spots appear. Here, at last, is the atomic structure of steel. Atoms of iron and carbon regularly stacked in all directions. Beyond this, nothing more is visible for the moment.